Now, next portion is width of the rotary. Now, the entry width and the exit width of the rotary is covered by traffic entering and leaving the intersection and the width of the approaching road. So, as the width of the road is more, in that case, your entry radius will be more. If it is less, in that case, your entry radius will be lesser. Okay. So this is the width of the approaching road. So based on the width of the approaching road, the entry radius and exit radius will be depending on that. Now IRC suggests that a two-lane road of 7-meter width should be kept as 7 meter for the urban roads and 6.5 meter for rural roads. So this is the width of the entry approach. Then further, three-lane road of 10.5 meter should be reduced to 7 meter and 7.5 meter respectively for the urban and rural roads. These are all are the specification for design the width of the rotary. Now, the width of the waving section should be higher than the width of the entry and exit. Waving section means this is the waving section, width of the waving section. Okay, this is the width of the waving section. So if the width is more, in this case, it can accommodate more number of traffic over there. Now this is the formula for the waving width. The waving width formula is E1 plus E2 divided by 2 plus 3.5, where E1 is width of the carriageway at the entry and E2 is carriageway width at the exit. Carriageway width means this portion. Okay, this width plus this width divided by 2 plus 3.5. Now, waving length determines how smoothly the traffic can merge and diverge, as we have already discussed. If the waving length is more, in such cases, the approach of the angle of approach would be lesser and the vehicle movement would be more swifter. It is decided based on many factors such as waving width, proportion of the waving traffic to the non-waving traffic, etc. Now, this can be best achieved by making the ratio of waving length to the waving width. You know what is waving length? So, this is the waving length and this is the waving width. So, you have to find out what is the ratio, and based on the ratio, you can design all the traffic parameters, all the parameters for the rotary intersection. Now, IRC has recommended a ratio of 4 for the ideal rotary intersection. Very large waving length is also dangerous as it may encourage overspeeding. So, as we have already discussed, if your waving length, that is this length is more, in such cases the speed at the intersection would be higher. So, you can increase the speed at the intersection by increasing the waving length. But in such cases, if there are huge number of traffic, in such cases, it can be proved to be fatal or dangerous. Then coming to the next portion, capacity, that how you can find the capacity of a rotary intersection. So basically, this is the formula to find out the capacity of the rotary intersection. So based on these, you can do some project like you can check whether the rotary intersection in your area is adequately serving or not. Okay, so first what you have to do, you have to find out the capacity of the intersection using this formula, where W is the waving length, L is the length of the waving, and P is the proportion of waving traffic to the non-waving traffic, and E is the average entry and exit width, that is E1 plus E2 divided by 2. So based on this formula, you have to find out what is the capacity, and after that you can find out the traffic volume by video photographic survey or manual survey over that intersection. Now, if the traffic volume over that area is more than this estimated capacity, in that case you can tell that your intersection, that is rotary intersection, is not adequate for that particular area, and you can go for the grade separated intersections on that area. Okay, so this formula is very much useful. Now, after finding the capacity and all the other parameters and designing the intersection, you can check whether your intersection is adequate or not. How you can find it? First one is your waving width at the rotary is in between 6 and 18 meters. It should be in between 6 and 18 meters. Your waving width, you have to design in between this. The ratio of average width of the carriageway at the entry and exit to the waving width is in the ratio of 0.421. The ratio of waving width to the waving length of the roundabout is in between 0.1 to 0.4, and the proportion of waving traffic to the non-waving traffic in the rotary is in the range of 0.4 to 1. So basically these are some parameters, okay, value of some parameters, so based on which you can check whether your design of intersection is okay or not. Hello, is it clear now? Okay, so tell me which portion you have missed. Me, so I will discuss this again. Okay, is this clear? This portion is clear? Okay, capacity. Okay, okay. So basically, the capacity of the rotary intersection can be determined using this formula. Now the thing is, this capacity formula is very much important to find out whether your intersecting road or whether your rotary intersection is adequate or not. So how you can check, suppose in your locality there are 5 number of rotary intersection. Now in some of the intersection you have encountered huge number of traffic congestion. Now you think of to check whether all these intersections are functioning properly or not. Okay, so for this reason, what you can do, first you can find out the capacity of the intersection using this formula, where your W is waving width. You know this, what is waving width? This is the waving width, this is the waving length, waving width and waving length. So you can find out this is W is the waving width, E is the average entry and exit width, that is E1 plus E2 divided by 2. Entry and exit width means this one plus this one. Okay, divided by 2, entry and exit width. W is the waving length. L is the length of waving. This is the waving length. P is the proportion of waving traffic to the non-waving traffic. Okay, proportion of waving traffic to the non-waving traffic means the portion Suppose some vehicles, what will happen? Some vehicles will be going directly in this lane. Some vehicles will be go around this intersection. So you have to find out the proportion to the this number of vehicles to this number of vehicles. This is called proportion to the waving traffic to the non-waving traffic. After that, you can calculate the capacity of the rotary intersection. Now, after calculating, suppose you have found out that capacity is 2500 vehicles per hour. So, this is the capacity of the rotary intersection. Now, how you can check whether your rotary intersection is working properly or not? After that, after estimating the capacity using this formula, basically this is theoretical capacity. Okay, after calculating the capacity using this formula, you can go for the traffic volume study in the intersection. You can find out what is the total number of traffic volume in the particular intersection area. Suppose for some intersection you have found out that it is 1000 vehicle per hour. In that case, it is okay. For some intersection, suppose you can found that it is 3500 vehicles per hour or 5000 vehicle per hour. So if it exceeds 3000 vehicle per hour, in such cases what will happen? The capacity of the intersection is basically overflowing. Okay, so for this reason what will happen, there would be traffic congestion in maximum of the cases, because the maximum capacity of a rotary intersection is 3000 vehicle per hour, but here in the actual case it is exceeding the capacity of the intersection. Therefore, in such cases you can suggest that here the rotary intersection is not suitable. We can go for grade separated intersection. So basically this is the usefulness of this formula. This is waving traffic to the non-waving traffic. Whether you understood what is waving traffic and what is non-waving traffic? Is it clear what is waving and non-waving traffic? Because other things you can understood by reading this note, but whether it is clear that what is waving traffic and what is non-waving traffic? Okay. Let me draw this. In that case, it will be better. Okay, so this is a intersection. Suppose these are the traffic medians or your channelizing island. So vehicle movement would be here in the direction, here in the opposite direction, here in this direction, here in this direction. Okay, now what will happen? Suppose some vehicles wants to go in this way. So what he will do? He will directly take a left turn. Okay, he will directly take a left turn. So this type of thing is non-waving traffic. Suppose another vehicle, he wants to go over there. So what he have to do? He have to go around this and have to take the right turn. Okay, so this is basically a waving traffic. Whenever he has to go around the intersection, go around this rotary portion, this is called waving traffic. And when he just can pass the intersection without go around this portion central island, in that case this is non-waving traffic. So basically you have to find out what is the ratio of waving traffic to the non-waving traffic. So how you can find out? You have to go for the traffic survey over that area, and ultimately you can find out what is the total number of waving traffic and what is the total number of non-waving traffic. Now is it clear what is waving and non-waving? Okay. Now okay, I'll take another 15 minutes. Okay, I'll just give one brief introduction about this one, and we'll discuss this in our next class basically. So in our next class, basically we'll discuss about the parking. Now, parking, you know what is parking, and parking is one of the major problems in the urban area, and it generally creates congestions basically in the urban portion where some market area is there or some shopping area is there, and basically this creates a huge problem. Okay, now the availability of less space in the urban area has increased the demand of parking space, especially in the areas like Central Business District. So, what is Central Business District? Central Business District is the prime location of the city where major urban activity would be happening over there. Okay, suppose some malls and some 2 or 3 malls and some other activities like some office and suppose some shopping complexes are over a particular place. So such places are called central business district, and in the central business district there would be huge number of traffic and there would be huge number of vehicles parked, okay, park in the roadside, because there are different activities which they need to perform. So for this reason in the central business district there would be huge problem for the parking. And besides the central business district, in other cases also, like in the market area, okay, you must have seen that the parking problem in the Naringi market area. You have seen that the effective width of the road has tremendously reduced because of the parked vehicles. So basically, parking in the urban area is a huge problem. Now there are different types of parking. So first type is on street parking and another type is off street parking. So basically the main problem is our on street parking. So on street parking is the vehicles are parked beside the road, like in the Naringi area or like in other areas of the Guwahati where vehicles are parked beside the road. Okay, so on-street parking means the vehicles are parked on the sides of the street itself, and this will be usually controlled by government agency system. Sometimes these on-street parking facilities are provided by the government. Okay, some parking places would be there, and government will charge some fees for that parking lot, and sometimes it is totally uncontrolled. Now, there are different type of on-street parking depending on how the vehicles are parked over there. Okay, so first one is parallel parking. Parallel parking is, suppose this is the road section, vehicles are parked like this way, parallel to the road length. Okay, so this is called parallel parking. Now this parallel parking is one of the safest parking because you can easily unpark from this area or from this portion. Okay, but here the thing is the length required for the parallel parking is more than the angle parking. Now, angle parking means you are parking your vehicle making some angles. Okay, making some angles. Now, based on this angle, there are different types of angle parking, like 30-degree parking. So this thing is not required for you. This numerical portion, like 30-degree parking, 45-degree parking, 60-degree parking, and right angle parking or 90-degree parking. Now, one thing you have to remember that as your angle of the parking increases, as the angle of parking increases, it will become more difficult. Okay, and the safety features of the parking would be reduced. So the most unsafe parking would be your 90-degree parking, and most safest parking is your parallel parking. Okay, and the most space required or length required is in the parallel parking, and for the 90-degree parking less space is required. But the thing is the 90-degree parking is most unsafe parking compared to the other type of parkings. Okay, so this is all about the on-street parking. Now, another type of parking is called off-street parking. Off-street parking means parking in the parking lot. Suppose you are going to a big in a big bazaar or in shopping complex. So you know in the big bazaar or in shopping complex there are underground parking facilities available over there. So this type of parking is called off-street parking, where they are located at a distance from the main road. Okay, and you can park your vehicle by paying some fees to the authority. This type of parking is called off-street parking. Now, another thing is whenever you are designing one building, suppose it may be a residential building, it may be a hospital building, it may be a restaurant, like that, you have to provide adequate space for the parking. So there are different space requirement for the parking. So for example, for residential plot area, from 500 to 1000 square meter, minimum 1/4 of the open area should be reserved for parking. So this means if your residential area is 1000 square meter, 500 to 1000 square meter, minimum 1/4 of the open area, suppose it is 1000, then you have to provide a 250 square meter of the area reserved for the parking. Offices may require at least one space for every 70 square meter as the parking area. Suppose your office area is your, suppose 280 square meter. So if it is 280 square meter, you need 4 parking space or 4 parking area. Then one parking space is enough for 10 seats in a restaurant. Suppose in a restaurant there are 100 seats. So if 100 seats is there, you need to provide at least 10 parking spots. Whereas as theaters and cinema halls, you need to keep only one parking space for 20 seats. So if there are 100 seats, you need to provide at least 5 parking spots. Okay, so these are the parking requirement of a area. Now, there are different ill effects associated with the parking. First one is congestion. So, whenever you try to park your vehicle in the road, beside the road, that is on street parking, it will create some traffic congestion. Then accident. So whenever you are parking or unparked from a particular area, it can lead to congestion and ultimately it can lead to your accidents. Environmental pollution. As for the parking and unparking, you need to stop and start your vehicles, and huge maneuver is also required, and you are creating some congestions in the road, so therefore it will create some environmental pollution for the area. And obstruction to firefighting operations. Suppose you have parked your vehicles in such a way so that it obstructing any firefighting operation, like you are obstructing the path of a vehicle or of a certain area where some fireworks broke out. So in such cases, you are obstructing such operations. So these are all are the some ill effect of the parking. Now, there are different parking statistics or parameters associated with the parking, like parking accumulation. So, it is defined as the number of vehicles parked at a given instant of a time. Suppose you are calculating the number of vehicles parked in an area. Now, if I asked you what is the number of parked vehicles at 7 p.m., so that number is basically parking accumulation. Now, another thing is parking volume. Now, if I ask you what is the total number of vehicles within 7 to 8 p.m. So, here I am giving you one time range. Okay, this is your parking volume. That is within the time range, what is the total number of vehicles parked over that area. This is your parking volume. Then parking load gives the area under the accumulation curve. It can also be obtained by simply multiplying the number of vehicles occupying the parking area at each time interval with the time interval. Suppose for 7 to 8 am there are 5 number of vehicles parked over there. From 8 to 9 am there are 4 numbers of vehicles parked over there. So your total parking load would be 5 plus 4, that is 9 into 2 hours. That is your parking load. Then average parking duration, that would be parking load divided by your parking volume. Then parking turnover, it would be parking volume divided by number of bays available. Number of bays available means these are the bays. That is the parking bays where you can park your vehicle. Okay. Then parking index is parking load divided by parking capacity into 100. Parking capacity, that is the total number of bays available over there. That is how many vehicles you can park over there. And what is the total parking load over that area. That is called parking index. And the last portion is parking survey. So in the parking survey, there are different type of survey. So first one is in and out survey. So in a parking area, you can take some your notebook and you can write down the registration number of the vehicles which are coming and going out of the parking area. So in this way, you can count the total number of parked vehicles over that area. Numerical example, it is not required for you. So another method is license plate method. In the license plate method, you just have to write down what is the license plate number of all the vehicles which are parked and unparked from the particular area. Okay, so let us finish the class for today.